So please, Nicolas.
All right. Yeah. Is it recording now?
Yeah.
Cool. All right. Thank you. Thanks everyone for joining. I'm Nicolas Papagna, for those who don't know me. And I'll talk about code coverage tool I've developed. Hopefully, I will be able to talk about everything I want to, but we might have to cut here and there to fit everything that I have. So the repo is this one. So you can find all the kind of the details about how it is built there and some examples. But I don't like PowerPoint, so we're going to do a real presentation here. And I said this, is there a hand raised or, oh, cool. So I said this is a code coverage tool. Code coverage is a technique used to kind of to measure the amount of code that is executed. We are used to hearing about code coverage in the context of automated tests, but the definition is more broad, right? It's like if you exercise some piece of code, it's a technique that allows you to kind of to see which part of the code was actually exercised. So there are many flavors of code coverage or criteria. The most basic one is just if a method was executed, you consider all the collaborations inside that method as covered. So as you can see in this example, I'm going to run this method, and it is covered 100%. The convention is you highlight in green the collaborations that were exercised, and in red the one that were not exercised, right? This is very basic, as you can see. It doesn't tell you much about what happened, because as soon as you send a message and you execute a method, everything is going to be considered covered, so you don't have much info here. Last time I checked, this is what Squeak has, and this is what Faro also has. So when you run code coverage in both systems, you are actually getting method coverage. The next step is called line coverage. As you can imagine, if a line is executed, then it is going to be considered 100% covered. But it has some issues, right? Because in this case, we have an early return here, but because we have two statements in the same line, then the whole line is considered covered, which is not really what happened. If we go one step above that one, we have a statement. This is what you're probably imagining. The coverage is measured at the statement level. So in this case, we get what we expected, right? Even though we have two statements in the same line, then the first one was executed and the second one wasn't. But a statement has some problems. And in the presence of branches, then you could end up in a scenario where I'm going to exercise this method with this collaborator set to true. So every collaboration is going to be covered, right? In this case, we have 100% cover under statement, but this is not actually true, right? Because we have an implicit else branch here, and the result is not the same when we execute this part and we don't execute that part. So statement, again, is a little bit better than line, but still have some issues, especially when it comes to branching. The next level of criteria is branch. So this one accounts for that. As you can see, I'm running this method with a boolean set to true. So the code is highlighted in yellow. I mentioned before that convention is green is cover, and red means not covered. I've added yellow to kind of to signal that this parse node was kind of 50% covered. I'm going to talk more about that later. So in this case, we send this message, but we didn't exercise all the branches. So if I add another test case now and run the code coverage, then you can see that this one is actually is considered 100% covered, right? But again, as I mentioned before, branches still have some issues, right? So we have we're sending the OR message here, and the result of this method depends only on this collaborator, right? Another boolean. So I'm going to exercise this method with boolean set to true and a boolean set to false. And as you can see, this is expected because this message was only evaluated on true in this case because we have an OR here. So it is considered 50% covered. And I'm going to go ahead and change the first collaborator. I'm going to set it to false. So we have true and false for the first test case, and false for the second one, right? And as you can see, this gives us 100% coverage, even though we didn't change at all the value of the collaborator that actually changes the result of this method. So depending on how you write the decisions, you can actually mask an object in the presence of another. In this case, a boolean is masking the way that another boolean affects the return of the method. So this is not nice. As you can imagine, there's another criteria above this one. In the books, they call expressions like this one decisions, and each part of the decision is called a condition. You can have nested ones. So condition coverage, instead of looking at the outcome of a decision, is going to actually take a look at the outcome of each condition. I didn't write a complex condition here, so this one will be the conditions here are going to be very, very simple atoms. Again, if we run this test case with true and false, then you can see that both objects are kind of 50% covered. I can go ahead and add the false test case where the first one is set to false. If I run it, then this one is covered 100%, and I'm still missing a test case to cover this one. And I can go ahead and add true, which is the value that is missing here, and then I will get 100% coverage under condition. But there's a problem here that condition only looks at the conditions and not the decision. And because I have an OR here in all these test cases, I believe, if I'm not wrong, let me see if I did this wrong. No, not this one. Yeah, this is true. It's true. Yeah, I messed up this one, but I could write a test case where the decision evaluates always to true because this is an OR, and still cover both conditions, right? So this is a problem that condition has, and the decision condition criteria actually merge both. So it looks at the conditions and looks at the outcome of each decision. We have one decision here and one decision here. So if I add this test case, everything is set to false. You can see that this branch was not executed. This one was, because each collaborator took only one value they are considered 50% covered, and then we can play here and start adding test cases to cover what is missing, right? As you can see, in this example and in the other ones I showed, we don't need all the possible combinations to get 100% coverage. So this is not strictly, I don't know how to say it, but this is not covering every input, right? Each criteria might require more or less test cases, but as you can see, this one, which is pretty precise, don't require every combination. So fun fact here, most code coverage tools work at the branch level, which is way behind the hierarchy here, sorry, this one. For those who use the IntelliJ IDEs, they have kind of coverage built in, but when you use it, they're actually doing line coverage for a reason. I don't know why. If you want to have branch, you have to go to the settings and explicitly enable branch coverage. I don't know why it doesn't ship with that turned on by default, but yeah, it's a good idea to do it. And as far as I don't know any tool that implements decision condition coverage. I don't know every tool out there, but at least the one I checked, they all stop at the branch level. So this one is pretty cool for quiz and I believe for the community, because it gives you an opportunity to explore what a code coverage tool that is more precise looks like and how it affects your measurements, right? While I was implementing all these criteria, I started thinking that it'll be nice to have this Boolean analysis beyond branching, right? Because for languages that have those reserved keywords like if or else or whatever, then those are the only kind of branching statements that you can have. But this is not the case, right? We have any method any object can implement their own control kind of messages. So you could have custom ones too. So I started thinking that if it was possible to extend this kind of coverage criteria when you look at something that is Boolean and check if all the scenarios were covered. And the first thing I did was I thought that it was nice. It would be nice to have the same analysis at the collaborators level when the message is defined, right? So if you have a method, you can just take a look at the collaborators, and then you can quickly see if one was used or one wasn't used. So in this case, I can add another case for the first one, just to see that this one turns green, means it was assigned both values, and this one was assigned only one of the two possible values, right? And once I did that, I started thinking about other options too. So let me run this test case. Everything is set to true in this test case. So the analysis, I extended the analysis for the temporaries. So this one was assigned. These two were assigned to one of the two possible values. This one is not used at all. Same for this one. True is 100% covered. That's a literal, so there's nothing to do there. And the end message only return one of the two possible values. That's why it's highlighted with yellow. This one doesn't depend on the collaborator, so it's just using this one, and it is 100% covered. And 0 was 100% covered, it's a literal, but the message that we sent to 0 only returned either true or false. In this case, was true. So that's why it's highlighted with yellow, because we're missing one test case to actually cover this 100%. Oops, what happened here? Something happened. Oh, this is the end. Sorry. So how are we doing with time? I guess we're doing good. I'm going to show you how this works. So this is done. So the way it works is the main object here is the code coverage analyzer. You give it a collection of methods that you want to analyze. In this case, I'm going to use a very simple method, which is actually part of the test cases for the code coverage. This is just referencing a little variable node. I'm going to create a collection with just that method. I'm going to create an instance of the code coverage analyzer with this collection. And the way you use it is you send the value method message with a block, and everything you do inside the block, if that exercises one of the methods that you provided, then they're going to be covered, right? Before I do this, I'm going to show you how it looks like from the UI side. Code coverage, right click, you can do run test, run test with coverage, or the whole package, right? There's some pre-processing I do, and we call it coverage, and then you'll get a browser that is pretty similar to the one you already know, but with extra info about the what happened, right? So in this case, we have this one. This method was only returned one of the two possible values. The other one is 100% cover, and the same thing goes for this one. Only one of the two possible values were returned. So behind the scenes, what is happening here? We work here. I'm going to show you a little bit how it works, not in detail, so you can have an idea of the things that are happening here. So the first thing that we have to do is to start tracking the code coverage. And this solution has something called the compile method analyzers. These are the objects that actually take a compile method. They're going to add some, for each parse node, they're going to add a message that covers that parse node when the parse node is executed. So we're wrapping every parse node here. And once we're done, we remove that method and restore the original one that doesn't have those tracing message sends. This is just an event for the UI to show stuff. We are skipping abstract methods. Those should not be executed. And I'm going to skip the source code generation, but I'm going to show you how it looks. And once we have these compile method analyzers in place, then we can plug an object to build a report with the information that each compile method analyzer is going to collect. And all the examples I showed before, from method to line to statement, those are just different report builders plugged into the same tool. So the tool is the same, and it's able to kind of implement the different coverage criteria. So this one is going to install the report builder for the condition decision, which is the criteria that I got to implement. There's a couple of more criteria above that one. I just stop there. And once we're done, we're going to evaluate the block that we were provided. And I'm going to execute this method now. And this is how the method looks like when it is traced. So if you remember, the literal variable was just a reference to this object. So there's a couple of interesting things here. First one, this looks like a symbol, but it is not. As you can see, it's well, this is maybe I don't know if we can see that here, but the way it works is when I'm recompiling the methods, I don't have the reference to the code coverage instance that I'm going to use. So I use a randomly generated symbol as a placeholder for that object. And when I'm about to execute those methods, I change the literal reference for, and I put the code coverage analyzer as the value of that association, right? So this is not actually a symbol. And the way it basically works is that there are a couple of different flavors for covering parse nodes. This one is very simple. It says that this parse node, when executed, so when this message is sent and everything goes okay, should register that this parse node was covered in the positions 20 to 25 in the original method, right? And an interesting thing is that this first message send that we have here, this is to tell, because the code coverage works by counting the amount of collaborations that we executed. If a method is empty, then you don't have a way to tell if it was actually executed or if it was never executed, because the collaboration count will be 0. So every method that we trace, we add this message sends, which actually tells you that. So if this was executed, then the method was at least executed up to this point. So we can tell the difference between an empty method and an empty method that was executed. Once we are done, we can ask for the report. I didn't show, I'm sorry, I didn't show the kind of the tear down for this one, but it's basically, we have to undo whatever we did here. We remove all the compile methods analyzers, and we install back the original compile methods. So as you can see, if we go here, then the original source code was the original compile method, sorry, was restored. Once we have a report, then as I showed before, we can open a browser similar to the one you know, with the coverage results. In this case, we only exercise this method, right? Is there any questions? I guess no. So
no,
I'm going to continue. Cool. So as I mentioned, this is the classic use of code coverage is in the context of automated tests, but it is not actually all that you can do here. So once I had this working, I thought, hey, how about if you can control when to start the coverage and when to end the coverage tracking, right? And this is what I call the async usage. And I think it's easier to understand with an example. So this is a very simple tool that I coded to kind of to search for stuff in the image. You can put object here, and you can browse to the object. Let's say that I want to understand how this tool works, right? So one thing I can do is I'm going to get the package for this tool, and I'm going to create a collection with all of its methods. Then, as I showed before, I'm going to create an instance of this code coverage analyzer, and this time I'm going to manually start tracking the code coverage. Then I open the tool. Let's say I want to find out how the class search works. Come here, type something, click on this one, and then I'm going to stop tracking the code coverage. And I ask for the report, and I open it. And here I have a picture of everything that happens since the coverage was started until the coverage tracking was stopped. And I don't know if the font size is right, but as you can see, the class name catalog was used 100%. The other ones, the implemented selectors of packages were not used. The only thing that was used from these objects are their name, which is needed for displaying their names in the tabs. And then the main object, which is the finder, right? What happened here? So this is another nice way or tool that you have at hand to understand systems, right? I believe it's not often considered to use it this way, but it's a pretty cool way to use it. And I believe that Chrome has something similar in DevTools. You can have start recording. I can't remember how it's called, but you'll end up with a report of the JavaScript code that was used during the time that you were recording. So this one was kind of an unexpected usage, but a pretty cool one, if you ask me. Yeah, and the thing I like the most about this tool is that I wanted to be true to the Smalltalk spirit, and I wanted the tool to analyze itself. As you can imagine, I blew up the VM more than once with an infinite recursion because the tool in the code coverage object is going to try to say, hey, my method was covered, and that information eventually was sent to an instance of code coverage, and that instance did the same, and you know how it goes, right? So I started thinking, what can I do to fix this and to have the tool analyze itself? And I tried a couple of different solutions, kind of trying to basically to tell if I was under that scenario, and I changed the objects, the solution to account for that. But first, the whole solution was kind of messy because you have to account for all of those for this scenario, right? And then I say, okay, I got to a place where it was kind of working, but I say, hey, if in the future I add a new method because I need that, and that method ends up being called when you report coverage, then that method is going to be a new source of an infinite recursion. So it was a solution that worked for today, but maybe in the future, if I add a new method, I'm going to start. I will need to do the same work again to kind of remove the infinite recursion for this new method that I just wrote. So after thinking a lot about this one, and I kind of thought that, well, this is not going to be possible, and actually came out with a pretty nice solution. The solution is you basically copy the entire package, and when you copy the package, you replace the reference with the new ones. And then you create a code coverage analyzer with the class from the copied package, and that's the instance you use to analyze the original package. Because methods are the methods that are going to be traced and recompiled will be recompiled on the package copy. Then the original one is not going to be changed, and everything works fine. So if we go here and say, run this package test with code coverage, this is, by the way, the code coverage package. I have a hat here. This is for showing something later. And we're processing, we're collecting the code coverage, and we have a report of the code coverage right? As you can see, it's pretty low. This is because I did it with TDD. No, just kidding. The coverage is actually pretty high. It's 84%. The reason it's low because all the UI stuff is kind of inside the same package. So just for making this thing easier to develop, this started as a kind of as a game. Like, can I build this or not? So it's not the tidiest code in the UI side. But the model side, which is all the objects that take care of measuring the code coverage, is pretty high. And you also get, I didn't show this before, but when you run code coverage, we account for the extension methods and things like that. So Let me see if I can find one here. Or maybe I didn't execute anything here. I don't know. I should have something. Yeah, this one. So you get covers for the extensions too. And if we have a little bit of time, I can show you how it works. It's kind of complicated, but just for you to have an idea. So I put a hold here. We are about to run the code coverage for the code coverage, right? So this is the code on the browser side, and what we're going to get the methods from this package, which is the code coverage package. And here we are in the code coverage analyzer, right? This is the instance creation method. It is created with it receives the compile methods to analyze, and the role is a factory, but it's actually a class that is implementing the criteria that we're going to use to generate the reports, right? So this is the big question. So we're checking whether any of the compile methods here belong to my system category. So if, for instance, I have this object is the code coverage analyzer, if this one appears here, then I know that we have to keep the kind of the meta coverage. So in this case, this is true because we are analyzing that package. So here's the magic. So this is the package where this class lives, and as I mentioned, the object that I called for doing that is called package snapshot. You provide a package and you get another one, which is a clone of this one with all the references and extension methods and things like that kind of worked out for you. Maybe we can see the package, Yeah, so I guess this one is one of them. As you can see, code coverage analyzer, where is it? No, I'm on the UI side. This one. As you can see, it was named with snapshot and a random number, and any reference to any class here should be replaced with the classes inside the copy. Right? I don't know if we have anything here, but we shouldn't have anything. Maybe in the compile method analyzer. Yeah, install compile method. This one. Compile trace method. Yeah, there should be. I guess maybe on the class side when we create this. Oh, this one here. This is the compile method analyzer. It receives a source code generator with this is the object that takes the original code and adds the tracing codes to it. And as you can see, the class that originally was this one was replaced with this one, which this one lives inside the package copy, right? Then I ask for a snapshot of myself. Remember that self is the code coverage analyzer. So snapshot of myself is this one. And I'm going to do the same with all the collaborators that I received to create a new instance, right? Then I send the instance creation method. Now we have an instance of the code coverage analyzer from the snapshot package or from the package copy. We have to pin this because as soon as the report is done, as soon as the coverage is done, it got garbage collected, and you still need that reference to ask for the report, so we have to pin it. Some methods to do some cleanup, and when this event is sent, then we know that we are ready to unpin this object. And then we proceed, and as you saw before, this is recompiling all the methods in the code coverage package and running the coverage on them. I don't know why they are failing, actually. I should take a look at that one. So yeah, that's all I have. Some things to think about. Going back to the Boolean analysis, the question here is that if it makes sense to extend it to other objects where you kind of know there's a limited set of options you can use. Another question that I have kind of in my mind is if it makes sense to do code coverage for class hierarchies, like say that a hierarchy is considered 100% covered if all the subclasses implement all the abstract methods, and of course, if they were executed too. Actually, I don't know if it's a good idea, but it should be pretty cheap to try, so I keep this question here. Another cool thing that can be done is, because we know for each parse node, we can tell from which test it was executed. Then we could implement what is called like delta coverage, which means how much of this test is exercising how much of this code. So it could be cool for providing refactoring support. Say you want to delete a test, then you know that you can tell if it's safe to remove, because there are other tests that are covering the same parse nodes, or maybe you're deleting the only test that happens to exercise that part of the code, and then you can say to go ahead or just cancel that. And another interesting thing is that kind of the architecture here is we wrap each parse node and we do some stuff. In this case, the stuff is measuring code coverage, but if we do if we measure the amount spent, like doing the before and after, and we plug a report builder that say collect that information, that we could have kind of a tool for doing the kind of fine-grained performance analysis. It'll be like an kind of instrumentation performance tool, not a sampling one, right? Again, this one is, I don't think it's as cheap as this one, but it should be possible to kind of hack the tool and try out if it makes sense and if it works. So yeah, this is all I have. And the repo is this one here. It is built in Quiz University, or you can install it in kind of in the regular Quiz images.
Thank you, Nicolas.
Sure. Do you have any questions?
So this package can be installed in Quiz 6.2?
I haven't tried it.
There is no,
unless Quiz University is running on 6.2.
Oh, because I remember in the past you have some you were using a patch VM for live typing or live typing. I don't remember. Yeah, please. Anand?
It is not depending on live typing, so it should be possible to run it on the stock Quiz image.
Yeah, guys, please go. Anand?
Yeah, I created a new version of Quiz University with a later version of 6.2. So and it worked. So I think it should work on 6.2.
Okay. Nice. Bernard?
Hi. Thanks for the presentation. It's quite impressive. I'm not sure are any other Smalltalks capable of doing statement or finer-grained code coverage? I'm not aware of any, but seems to be a first, no?
Yes, I tried in Squeak and Faro, and they do method coverage. I believe it's because Squeak did method originally, and Faro took that from Squeak. I believe they never changed it, at least until last year, which was the last time I checked. But I'm not sure about Bast or the other small talks. Yeah, it'd be good to know that. Yeah.
I have never thought about how to implement that. So maybe that's a stupid question, but so are you somehow need to handle special methods, specially like and or if true, if false, and things like that, and
Yeah.
the same with objects? No.
Yeah, this is a great question, and thanks for mentioning this. When I am about to generate the trace version of a compiled method, I decompile the method without the optimizations, because in that case, you won't be able to trace those special selectors like true or false. Yeah.
Mm-hmm. No, but I meant I didn't mean it like that. So I'm not sure how to ask this, but so there are variables in code, yeah, and some of which are booleans and others which are normal objects like strings or so. And I would guess that the booleans have a special meaning when you talk about code coverage, or other objects of other types. It's not the case. Do you
Yeah, I think
understand
that.
better what I mean?
Yeah. So as you mentioned, booleans are kind of analyzed in a special way. As I showed a lot of examples where they were highlighted in yellow, and that analysis is made on the booleans object themselves. And then if any message returns a boolean, it is considered a boolean method, unless it returns a boolean and something else. So as soon as you return something that is not boolean, as soon as you return something that is not boolean, we're going to skip the check, right? The boolean check.
This is statically analyzed.
This is analyzed at runtime.
At runtime. Okay.
Yeah. So we're kind of picking at the results of the methods, and if they return a boolean, then we consider that the method is boolean, unless it returns a boolean and then in the next run it returns a number, and then it's no longer a boolean method, right? The same analysis goes for the collaborators. So if you send a message with true or false, that parameter is going to be considered boolean. But if you exercise it with true, false, and 1, then it is not longer will be considered a boolean. Yeah. So and the question that I have. Yeah. Sorry, go ahead.
If I would I don't know write a different kind of if true, if false, which just renamed but with the same semantic, it would basically work as long as it's really boolean, it's in the boolean classes, true and false.
Exactly. Yeah. Okay. You could have true and false in any random object that you implemented. And the thing about true or false and all those methods is that I don't have a list of them, like, oh, these ones I should check. Those happen to be methods that only return either true or false. And that's why the Boolean analysis kicks in. If you have your own control structure, and that selector returns either true or false, then you're going to have the same kind of analysis that if true and if false have. So I don't check them explicitly. Yeah.
So the only problem would happen if I had my own kind of Boolean hierarchy with I don't know a different kind of logic. So then that would need then a special coverage for that class hierarchy. Okay.
Yeah, let's say that you have kind of a ternary logic, right? Yeah. Then you'll need to kind of have a plugin to consider the three values, right? If the stock analysis doesn't work for you. So when I mentioned that if it in the future work, if it made sense to extend the analysis beyond Booleans, is exactly what you mentioned. maybe you have your own objects and you want to have specific values for covers depending on their values. Like, let's say that it is 100% where all the three values from the ternary logic were provided, right? So that is the open question. That if that is the case, then can we extend the analysis to, can the user extend the tool to cover for those needs?
Yeah.
Yeah.
I can imagine use cases like the variable should be nil and not nil, or there has to be a negative number or a positive number, or a large integer, small integer, things like that. But well, that's all. I'm only, I'm not sure if that would be very useful. But thanks for the answers. Very great stuff.
Sure.
I would like
Hernan has a question.
No, not a question, but the last time I used coverage in via Smalltalk, it was method coverage. That was something you asked, Bernard.
Interesting.
I don't know about visual works. I have no idea.
I have one question.
Yeah.
Maybe it's a silly question. I don't know. You show example of method coverage with boolean parameters, right? What if it is other kind of object like float?
Well, those kind of objects, which are going to be considered literal objects by the tool, like the literal parse nodes, they're going to get 100% cover, right? Let me show you an example here. I'm going to share my screen again. Let's see if we can. Right here, or no, not these ones. Let's open the presentation again. I guess it was this one. This one? I'm not sure. Yeah. So in this case, if you ever send one, say as a collaborator, or you just mention it explicitly, that is going to be considered 100% cover. In that case, we don't do this analysis, and it's either provided, it's either used or not used. That is the criteria for considering something that is covered when it is not Boolean.
Sorry, maybe I explained. I mean the attributes of the method.
You mean? Let's see if we can code that, and it'll be easier to see here. I'm going to add a new method here. I'm going to go test, and you are going to provide something here, right?
Integer or whatever.
We're going to do something. This is not maybe this is not the best name. Let's do this one. Yeah. So let's create here a collection. Oh, sorry, no, it's this one. Yeah, a collection with a method that we just created, a new instance of this one. We are going to create a new instance of that object, and we're going to send this method with 1, for instance, 1.5. Report. And as you can see, it was covered 100%, right? If let's say that we remove this and we run the same thing again, then the method is 0% covered, and the collaborator, it was not used, so it's 0% covered. So the way coverage works with the collaborator is it is either used or not for non-Boolean objects, and then the Boolean analysis kicks in when they are Boolean. I don't know if this answers your question.
And this is the same if you have you test the value of x, it doesn't change.
If you test the value of x, like
yeah, if you test
like
if it's belonging to one range, or it's between something. Or...
Yes, as soon as you use it, it's going to be considered covered. There's no special analysis for numbers.
Okay, so but okay, maybe I misunderstand what you are doing exactly. Maybe, yeah.
You mean for the collaborators?
It's not the when you say code coverage, it's not. Does it not mean that you are you are testing all the situation of the code in the method? I mean, if you have branch or thing like that, or not?
Yes, for branches, yes, but I'm not testing kind of possible inputs, right, beyond Boolean. For Booleans, we do that analysis if both values were provided, but for the rest of the objects, no. It's just going. If you provide a collaborator, then it's going to be considered used if it was used. And we take a look at branches and conditions, but just that. We're not checking anything about the input domain, to put it that way, except for Booleans.
Okay. Yeah, I mean,
one of the open questions is
it's not possible anyway.
Well, one of the open questions is that what if I want to? For sure, there's better options, better solutions to this thing, but they say that this only takes numbers in the range from 0 to 10 and from 90 to 100 for whatever reason. Maybe you want to customize the tool to account for that. And for this method, you want that analysis to kick in. It should be possible because that's kind of the infrastructure in place to do that for Booleans. It should be possible to do it for other kind of objects. But no, we don't do anything like that. Just Booleans.
Okay.
Yeah.
Thank you, Nicolas.
Sure. One thing to mention, maybe Juan knows better. Juan, when you presented your quiz dynamic libraries last year, the first thing I thought was I could replace the package snapshot with that thing, right? I created a library out of the code coverage package, and I load it back. And that way I could have a copy, but because I believe that most of the things a lot of the things that I did, you already accounted for when you did the dynamic libraries, right?
I don't quite understand the question, but I try to answer what I got. A library can define a set of classes. If you try to load a library twice, you will not get duplicative classes. A Smalltalk system can only have one class by some name.
Okay. Yeah, so maybe the machinery...
Unless you talk gemstone. That is a bit special.
No, I thought maybe the machinery was in place that when you restore a library, you could change the names. But yeah, that was a random thought that I had when I saw your presentation.
Okay. Yeah, but no, we don't do that. We don't do rename or anything like that.
Yeah, makes sense.
Bye, Anand. Yeah, we are mostly 1 hour anyway. So, if we don't have any more questions, we can stop there. At least I can stop recording the presentation.
Thank you, Nicolas.